Hello, so in this network, can you apply a Kirchoff's voltage law, that is KVL? Yes, we can. How? So remember, KVL states that the algebraic sum of all the voltages around the loop is equal to 0. I repeat, the algebraic sum of all the voltages around the loop is equal to 0. So this is a linear circuit consisting of a voltage source and the two resistors in series. So let's see how many voltages are there in the circuit and just sum them all together. So there is this voltage source, clearly Vs, and because of that there is a current that will be sourced from this voltage source. This current will flow through R1 and R2 like this, and it will return back to the negative terminal, and that is what precisely this current I is shown. So when this current I is passing through R2, it produces a voltage drop across it called as VR2. Let's say the voltage drop across R2 is VR2 due to the current I. Same current passes through R1 and it produces the voltage drop across R1. Let's call it as a VR1. So how many voltages we have? Vs, VR2 and VR1. So therefore we can write KVL as Vs plus VR2 plus VR1 equal to 0. That's nothing but your Kirchoff voltage law. It says that sum of all the voltage inside the circuit in a closed loop is equal to 0. That's it.